Hi, everyone. Welcome back to the OnTrack podcast. It's Judy Warner. I'm so glad you can join us again this week. We have a returning guest today, someone you'll recognize, who's Chris Hunrath, the VP of Technology at Insulectro. Chris is going to talk to us about a new MSAP technology, except it's not really new. It'll be new to you, I think, and I think you'll learn a lot about it. So lean in, enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hey, Chris, nice to have you back again.
Hi, Judy. Thanks for having me back.
How's life up in San Jose and Silicon Valley these days?
Slowly getting back to normal, little by little. So
Getting gridlock and that good old-fashioned traffic you guys suffer from up there?
Yeah, I never thought I'd be glad to see traffic come back, but that just means things are getting back to normal.
I know.
Not bad.
I know. I went on a flight about a week ago, and there was like full airplane, no spacing between, babies crying and people fighting with overhead space on the airplane. It's like, oh, thank you. I never thought I'd be thankful for these everyday things. Well, thanks again for joining us. I wanted to talk a little bit more about something I've been hearing more about sort of at large, but you tell me it's something you guys are really dipping your toes into, and that is MSAP. But for our listeners, and to remind me too, also, can you define what MSAP is? And there's also just SAP. So
Yeah,
give us a
right.
definition to start.
Yeah, so briefly, so it's really SAP is Semi Additive Processing, MSAP is Modified Semi Additive. Really, the difference between the two is one, you start by adding an electroless copper layer, seed layer, if you would, that you can electroplate onto. And the other modified semi-additive process is you would laminate on a ultra-thin foil. We have some products and technologies that work with both. The traditional way to make a printed circuit board has been what we call subtractive process, where you take a copper-clad material of some sort and you print and etch it, and that's purely subtractive. And the reality is every common circuit board today is a combination of additive and subtractive, right? The foil layers are printed and etched, and then the plating is done to link the layers together, and that's an additive process. There were some older technologies where a board could be fully additive, a PCB board. That's kind of lost favor just because it wasn't good for high density circuit boards, multi-layer circuit boards. It was more suited to high volume double-sided. Now, a semi-additive process is very common. It's used for chip substrates and the like packaging, semiconductor packaging and the like, because you can achieve some very small architectures. And that is one of the appeals of the process. Because of what board shops are capable of doing, they do something more traditional or something that's larger. But we're always pushing density limits, right? As chip packages are getting more, not just more dense or smaller, but also more capable. I mean, the pin architectures have gone through the roof, right? The number of pins you can have on a BGA. And then, of course, you can shrink that pitch down and either, add more IOs or just have more packages on the same PCB. Or in the case of a mobile device, more packages inside the mobile device.
Right. So I swear it seems like every week I'm seeing more and more about SAP and MSAP, and somebody's posting something about it. So I assume that means it's sort of rising in interest and popularity. Why am I seeing so much of it lately?
I think there's a couple of things happening at the same time. One is there's a need to increase density, right? And that's a moving target, right? As more devices are put into a chip package, more packages are put on a PCB. there's a desire to have more density, more functionality. Don't forget that we're combining in almost every device now RF and high-speed digital. It's almost always those things are combined. But then you also have technology improvements that are happening at the PCB shop, right? So LDI imaging, which has pretty much replaced the old silver artworks, those machines continue to get better and increase their capability in terms of how small they can make the circuits. Well, what can you do with that? Well, it depends on what you're trying to achieve. If you can print and etch a very fine line on 9-micron copper, for example, that might be great for density, but if it doesn't have the thickness or the bulk copper, it could be very bad for signal integrity. So a semi-additive process, you can fix some of that. And that's some of the things that I'm hoping we can talk about today.
Right. So, for the amateurs like me out there, I'm always going to have to go to the Chris Hunrath dictionary, but I believe LDI is laser direct imaging, right?
Yes, that's right.
Right.
Yeah.
And it
Yeah.
used to be about
Yeah.
photolithic, right? Where you would just expose it to light
Right. Yeah.
as opposed.
So a little history. Um, at one time, circuits were painted on wax. In other words, you would use wax as your etch resist, and someone with a brush would draw the circuits on the copper. Let's call it foil. It was probably thicker, and then you would etch in chromic acid, and then that's how you'd end up with circuits. There were probably some 1920s vintage radios that were done that way. And then in the 40s, late 40s, photo reproduction was developed. But
Mm.
even after that, circuits were done were screened on with an ink, and then etched. And then, of course, when photo imaging became popular, that's how things are still done today. That's how you can mass produce circuits. But the artwork master was made, and the LDI machines basically eliminated that. You're actually writing the laser image directly into the photoresist instead of using an artwork master. So, and that evolution's been happening the last 15 years, but
Hmm.
it's really taken over the industry. But the machines continue to get better. So their pixel size and the type of circuitry they can do continues to get better and better. So you can now in a PCB fab you can image much finer lines than you used to be able to do. And so I think that's one of the things that's driving the opportunity to design with MSAP rules, if you would, or SAP rules, semi-additive rules, where you couldn't do that before. That and the photoresists are getting better. The Veritech process offers a PCB shop scale way to do a semi-additive process because they have the plating products to get that seed layer down, and then of course the ultra thin foils that are now available. So all those things are coming together, and of course there's always an increasing need for density.
Yeah, it seems like we're driving more in the direction of ICs, right? We're getting tighter and tighter and tighter. And, traditional board manufacturing methods just could never get us there. They were not precise enough, which is, I'm sure, what this technology in some ways helping us get there. Um, so, since our listeners are mostly design engineers, what's in it for them? What sort of benefits and implications are there for them when they're designing? If they want to, have a really dense design, what does this do for them?
So one of the things is it allows you to change the geometry of the trace. So typically traces were always wider than they were tall, and with a semi-additive process, whether it's modified or not, you can kind of flip the trace or stand it on its side, so the trace can be taller than it is wide. Now that opens up all kinds of possibilities from a design standpoint. Now you need some dielectric materials to go with it, but those are advancing as well, and that will open up some opportunities. So one of the challenges is when you have a particular chip package with a pitch, let's just say it's 0.5 millimeter. How many traces can you put between the vias, in a package like that? Well, with MSAP, you can turn those traces sideways, and they can be taller than they are wide, and now you're not sacrificing signal integrity. In fact, you can do broadside coupling on differential pairs in that way, and you can both meet the impedance on the differential pair and meet the impedance between the reference plane, um, just differently because you've got different dimensions on the traces.
Hmm.
How it's coupling to both the reference plane and in case of differential pairs to each other, and that kind of opens things up.
Well, you'd mentioned that, there's sort of RF and wireless technology, it seems like baked into everything today, especially with the proliferation of IoT. And one thing I remember when I worked with RF engineers is when they would do simulation, what they simulated and the boards that I sent them didn't always match. And part of that was because the lack of precision in the geometry of the trace. It might look more like a trapezoid where they modeled it as a perfectly vertical side trace. And then, but they, again, not knowing much about manufacturing, is like, why is what I simulate it not what I have coming out in the back end? Do you think in that regards it will also help simulations more closely match what they get out the back end?
Yeah, it will. Yeah, because what's happening is when you print and etch, you're putting a photoresist on the surface, and you're etching in 3 dimensions. Well, really, it's more like 2 dimensions when you're dealing with a photoresist on surface. So the photoresist is not going to etch. The exposed copper will etch, and you're etching laterally the same time you're etching down, and that's where the trapezoid comes from. But with a
Right.
semi-additive process, you're putting in the photoresist, and then you're developing that trough where the photoresist has been polymerized all the way down to the base. Because it's light and it's going through the material, it's not like the etch chemistry. So you can define a pretty good vertical sidewall, and then you fill it with plating. So the photoresist really becomes a mold for the plating, and
Oh, that's cool.
the circuit geometries are much more um, precise in that
Hmm.
case than they would be in an etch process, print and etch process. And of course, the thicker the copper, the worse the etch factor gets. So
Right.
yeah, so I mean, I've seen customers try and do 6 mil lines, with 2 ounce copper, and they're yeah, they're a mess. But if you were to plate them up, it would be a different story. You'd get much more precision sidewalls or much more
Hmm.
vertical
Hmm.
sidewalls. But I think the real opportunity is putting more traces between tight pitch BGAs. I think that's a big advantage of this. And mixing technologies just become a lot easier. The term I used earlier was unleashing the designers, right? You take away some of the restrictions that they've been stuck with because they're working with a fabricator that has manufacturing rules, and this changes a lot of those things. The One of the challenges will be is getting everyone on the same page when it comes to what is doable in the board shop and what the designers want to do. But I think it's a great place to have some dialogue.
Well, so, thinking about our listeners here, how, how many board shops is this? I mean, is this capacity available, becoming more widely available both in the US and for our European listeners and maybe Australia? Like, how far flung is this technology at this point?
So the good news is most board shops are equipped with the right exposure units today. And it depends on how far down you're pushing the limit. If you're doing most board shops I think can do 2 mil, 50 micron wide features, all day long now. There are many that can also do 25 micron or 1 mil features. Um, so from an imaging standpoint, a lot of them already have the capability. And plating wise, it's not any worse than plating a microvia. I think the challenge would be is that in some cases they'll need a high resolution resist if they're trying to make a trace of let's just say more than 50 microns or up in thickness. They'll need a high resolution resist, and they'll need a starting point, and that could either be the ultra thin foil or the something like the Veritech process. Um, and either way will work. Again, one process is better suited for volume than the other, but either process can work. The advantage of the foil, of course, is that a shop can start small. They could do a couple of pieces. And of course, like I said, the Veritech has the advantage of making it a more mainstream process within the PCB shop.
Right. Well, I will share, by the way, I did a previous podcast with our mutual friend, Tara Dunn, who is now VP at Veritech. And I know she and her team have been pushing hard to get this into more places here in North America. So, but that's good to hear that the laser direct imaging gives them the capability, because then they only need to onboard the chemistry or use the ultra thin film, right?
The ultra thin foil, right?
Foil,
Right. And
sorry, that's what I meant.
yeah, I think Veritech's in a good position right now because they're entering this at the right time. Because of all these things converging. The fact that the imaging the systems are getting better, and the plating systems are getting better, and the need in the industry is there.
Yeah.
To go down this path. Um,
So as far as Insulectro goes, then you're seeing more of this, as your role at Insulectro. Is that something then Insulectro is offering, is the ultra thin foils, or what
we
are
do have
you
the thin
offering to?
foils.
Mhm.
Yeah, we have the thin foils, but we also offer the photoresist for that technology, which you'd use for either the Veritech or the thin foil.
And
Now,
is that
some of the
photo
photoresists are capable. I'm sorry.
is the photoresist thicker? Because you said it creates a mold or a
Yeah,
trough.
that's
Is it thicker?
typically you would want to use a thicker resist than you would use for standard interlayer imaging. Oh no, not always. Most interlayer resists are about 1.2, 1.3 mils. So if your plating if you're only plating a mil, those are fine. But if you want a 1.5 mil to 2 mil trace, you might need a different photoresist. And we have those products. We have the full range of those products. So through DuPont. So folks could use those again with
Okay.
either the Veritech process, an additive process, or the foils.
Okay. Well, I know you recently did a webinar about that, which I'll share the link with our listeners. What do you cover in that webinar? And I think you also have some other webinars that our listeners might want to know about.
So I do have a 50 ohm differential pair example, in that webinar, as well as some more details on the photoresist and on the foils. So that webinar is probably I would say 70% PCB fabricator and 30% designer. But there is some good, information there on how a designer could see the possibilities of how they could use this technology from a design standpoint. What they can do, but basically it takes away some of the restrictions they may be used to.
And what other type of webinars have you been doing lately, Chris?
Well, we've done one on copper foil because copper foil it's not just a commodity anymore. The properties of the foil, the bond treatments, how smooth it is for high frequency. That's been a topic. We've done one on high speed laminates. We've done one on flex materials. So just a variety of stuff when it comes to PCB technology.
Okay, well, again, for our listeners, I'll make sure I share all this with you in the show notes below. But I just wanted to get Chris in for sort of a quick and dirty podcast today to tell you about MSAP. So before you go, I want to ask you a funnish question.
Okay,
Are you ready for it? Okay,
sure. Go ahead.
during COVID, what has been your guilty pleasure? Movie
Oh
binge,
gosh,
ice cream.
I have an
What's your
answer for
guilty?
that. So
Okay.
I have a small pizza oven that goes on top of my grill, and I've been
Oh,
buying pizza dough. I'm not making my own pizza dough, but I'm not making frozen pizzas either. So I've been making a lot of pizzas. So basically, I roll out the dough and put up the toppings, and this oven goes on my outdoor grill, and it gets to like 800 degrees, and it cooks the pizza in about 5 minutes, and it does a really nice job. It's very different than cooking in your regular oven. So
that's
that's
super
been
fun. So who makes that pizza oven? Because we all need one now.
It's been good. It's been a nice distraction. I've been eating like a lot of us have been eating at home more. Not so much
Yeah.
now, but during the lockdowns.
Hmm.
So it was a nice way to basically endure the lockdowns. And I've been doing
Yeah.
a lot of bike riding too. I've done more bike riding this year than I have in a long time, and that's kept me from being overweight from the extra pizzas that I've been eating.
That's good. You're writing off all the pizza.
Yeah.
What's the brand of the pizza oven?
Oh gosh,
Do you know?
I'm trying to remember the name of it.
Okay, well, or you got to send me the link because now
I will. I
everybody,
will. Yeah,
including me,
it's
wants the pizza oven for their grill.
I got it through Best Buy's website. Believe it or not, Best Buy of all
Okay.
places. Yeah, through their website. Yeah.
All right. Inquiring minds want to know. You'll have to share that later.
There
Well,
you go.
thanks so much for coming on today, and I'm sure we'll have you back again before long. It's been good to catch up with you, and thanks so
Yep.
much for telling us about MSAP today.
Likewise, Judy. Thanks. It's always good to chat about technology.
Yeah. For our listeners, thanks so much for joining us again this week. Make sure you like, subscribe, and, you know, give us some comments. We want to hear from you. What's your COVID guilty pleasure? Or, whatever. What's your favorite pizza? Whatever. Let's chat. We're all locked in still, at least slightly, except you people in Texas and Florida. So, anyways, we'll see you next week. Thanks for joining us this week with Chris Hunrath of Insulectro. We'll see you next time. Until then, stay healthy, stay safe, and always remember to stay on track.